Good afternoon, all. My name is Sharad Kadam. I'm representing Nemetschek India. So today's topic will be about the precast efficiency using Allplan. So a brief introduction, as Shweta has already given an introduction about myself. So I had more than 22 years of experience, mainly into precast, and I have covered mainly regions from USA, Europe, UK, and mainly into precast detailing, rebar detailing, beam services, bridge engineering, and infrastructure projects. So to start with, the Nemetschek is established in 1963. A brief introduction about the Nemetschek. So it is established in 1963 by Professor George Nemetschek. He was a professor in the University of Munich, and based upon uh, his expertise and the knowledge that he has started the company for the Nemetschek, and the company mainly deals with we have a variety of softwares to start with. So we mainly deal with the four customer segments. So total we have about 14 strong brands, and our revenue is close to 1 billion, and our globally we have more than 7 million users and more than 3,600 employees. We are into the AEC segment, so we are into planning and design, wherein we have some softwares related to planning and design. Then we have softwares related to building and construct, operate and management, and media and entertainment. But today's topic will be more or less concentrated on the precast segment. And these are the various softwares that we deal in India. So to start with, for the architectural side, we have softwares for conceptual designing, landscape, interiors, and which is Vectorworks. Then we have software which is Graphisoft, ArchiCAD. This is for the schematic detail design and GFC drawings. Then for the design analysis and design purposes, we have a software called as RESA, which is basically for which does a complete structural analysis and design. It also does the PT tendon scaling and all. And for the detailed design, precast, bridge segment, we have software called as Allplan. So today's concentration will be on the Allplan side. Then in the steel segment, we have software for steel detailing, which is SDS2. And for the CDE, we have Bill Plus, so a cloud-based platform. And across the platform, we have Bluebeam and Solidly. So all these products belong to the Nemetschek family. So to start with Allplan, so Allplan is basically for modeling, detailing, fabrication, and it's for steel. So for steel, we have something called as SDS2, and for concrete, precast, bridges, we have Allplan. So the software can be used by engineering sites, such as civil engineers, bridge engineers, structural engineer, precasters, and construction management, and general contractors as well. So to start with the Allplan, so Allplan is basically for modeling and designing, documentation, automation, and detailing. So we can do the complete precast projects. So whether it's irrespective of whether it's a residential commercials or it's a stadium project, bridge projects, so we can do this in Allplan. So to start with the precast, so we have nearly 30 plus years of experience in industrialization constructions, and the software is dedicated. It has dedicated tools for modeling, drawing generation, and once the modeling and drawing generation is done, the next part comes up is the post production or the productions. So our tools are useful for the production part as well. Worldwide, we have 600 plus Allplan customers. Mainly, we are concentrated on the Germany market, but other than that, the complete European side as well as UK and US, we have customer base. Total 150 billion meter square of precast concrete elements are casted every year with the software that with the Allplan software, which our customers are using. So Allplan precast is basically for elements wherein we can it's basically an efficient tools for all the elements such as walls. We have dedicated tools for walls, slab, columns, and beams. Also, we covers various types of stairs and foundations. Other than that, there are structural and volumetric precast elements can also be covered with Allplan. So this is something which is very interesting, wherein we can create a complete volumetric element. So generally, it is called as PPVC or pods, wherein a complete walls as well as slabs can be casted at one go. So design, we can do the modeling in 2D or 3D as per our requirement, and drawings can be edited at any point of time. So we can create a shop drawing and the shop drawing can be edited, and whatever changes we are doing in the shop drawing, the same changes automatically get updated in the model as well. So drawings are 100% consistent at all the time. So it won't happen that my drawings is getting edited and my model is not updated. So whatever changes we are doing into the drawing, the same changes will get updated in model, and it's vice versa. Let's say we do some changes in the model, the same changes will automatically get updated in the drawings as well. So what we can do with the tools, we can create shop drawings, we can add rebars. To start with, we can add concrete, geometry, then we can add reinforcement. So once the reinforcement is done, we can add fixtures to it, and after the fixtures, we can go to the drawings with for creating labeling and dimensioning part. So to start with slabs, we have various kinds of slabs. Nearly all the different varieties of slabs can be covered here. So to start with, we have solid slab, which is a normal solid slab that we can cover. Then we have hollow core or the pre-stressed slab, wherein pre-stressing cables or tendons are added into it with hollow cavities inside it. Then we have double decks, or it's also called as coaxial slabs. Then we have girder slabs as well. So these all these slabs can be modeled and drawing can be generated from Allplan. We have brick slabs as well, the insulated brick slabs as well as concrete brick slabs, suspended brick slabs. So these are the various types of slabs that can be handled with the Allplan. But most of the cases, yeah, one thing that I missed here is the double T. The double T can also be modeled with Allplan. So majority of the times the slab that we are using is solid slab, hollow core slab, and the double T, as well as the girder slab. So all these varieties of slabs that are majoritarily used in Indian market as well as the European market or US market is covered with the with the possibilities of Allplan. So here are some of the drawings that I can share. So, sorry, to start with, we can create any kind of geometry for the hollow core. So let's assume, we have a big library wherein nearly all the hollow core providers, we have the database with us. But other than that, if some different hollow cores is there, then we can create with our tools. So here we have the edge geometry. So we can create any kind of edges that we are having for hollow cores with the tool. Then, other than that, there are hollow inside slits. So any kind of hollow sections can be created with the tools, and this can be combined. And here it is how it is laid. So it's the logic is something similar that how we can do it in a 2D geometry. The same logic is applied here. So let's say we need to have 1.2 meter of slab thickness or slab width. So we can specify it over here and how much cavities are required and what is the type of cavities, what is the offset in X and Y directions is specified at this location. And this database, once it is done, so we can use it across the projects or across any project that we want to use it. We can have any number of precast slabs like this with a variety of profiles. So this is about the precast slab or rather the hollow core slab. So once the cross section is done, we can add the longitudinal sections as well as the end face sections. So, and we can specify where the cut is needed and where the cut is not needed. So all these things can be specified in the actual initial stages itself, or it can be modified at the later stage as well. So that's about the hollow core slab. So moving on to the next part, which is the mainly in precast, we have a majority of hollow cores or rather slabs as well as walls. So the second important element which covers into the precast segment is about the walls. So we have nearly all the different varieties of walls which is possible. So most of the cases it's solid wall, which is a maybe 150 mm to 300 mm thickness based upon the design. So we can cover that and we can add rebars to it based up as per the design intent that we see. Then we have thermo walls, double walls, as well as brick walls. So generally brick walls are used in European countries as well as the sandwich walls. All these varieties of walls can be easily taken care or can be easily handled with the inbuilt tools from Allplan. Then we have automated reinforcement. So once the concrete geometry is done, the next part comes up is the reinforcement. So we can add reinforcement manually as well as we have tools, which is basically called as Python parts, which are useful for adding the rebars to it. So with these tools, we can add rebars for the complete face or let's say a number of walls based upon the design. So let's say we need to add some walls reinforcement to some peculiar elements. The good thing over here is the tools automatically cuts the rebar at the opening locations. So many of the times it happens that there are other softwares are available in the market. So in that scenario, we need to cut the mask manually, or if we need to have any additional rebars to it, or if we have opening above opening, we need linters like then we need to cut the we need a beam kind of reinforcement or stirrups. So all these things can be handled with Allplan, and we can decide whether we need to cut the rebar at opening or if it needs to be cut at side. So all these things are if we need some special rebar at openings like a 45-degree bar or extra bars at top and bottoms. So these things can be easily handled. We have the options for adding mesh as a reinforcement. So we can choose whether we need normal rebar or mesh. Then again, we have something called as spacer bars and clamps. So generally, spacer bars are used to keep the space between two layers of reinforcement. So if it is required, then we can add it, or we can, if it is not required as per the design, then we can skip it. So once this is added, so we can choose it and we can see how, I mean, if it is as per the design or here we have taken roughly about 4 to 5 different walls. So we can choose to modify any particular wall or all the walls at one time. So these tools are very efficient in modeling, and nearly all the rebar can be modeled with this. But other than this, we have something which is called as the manual rebar detailing, wherein we can, once my macro is done, we can go ahead and do the manual rebars as well. So once the rebar is added, the next steps comes up is adding the fixtures. Here we call it as fixtures, some software call it as component. So basically any kind of inserts that go is inside the elements is called as fixtures over here. So once the fixture is added, whether it's a lifter, whether it's connecting to the side walls, or the bottom connection or top connections, we can add it in the all plan. The fixtures can be easily created. So if there are something which is specific fixtures related to some different companies, then we can create the fixtures as well. Once the fixture is created, the next part comes up is the shop drawings. So these are the some of the shop drawings that I'm showcasing. So herein minimum to no manual work is done. So herein we can see that with the shop drawings we are getting the bill of materials. So whatever elements or whatever inserts pictures that are added inside the wall is also getting highlighted over here, or it is getting the listed. We also get the wall list wherein the complete data, length, width, thickness, grade, weight, ton, volume, all these things are highlighted or can be obtained inside the drawings. Again, it is customizable, so if there is changes are needed, we can do these changes in here. So this is just one example for particular walls wherein electrical inserts as well as bottom connections and top connections with fixtures and all is added. One more example over here. So this is again a typical Indian projects that we can see. Bottom ground tube connections and top dowel connections. Sideways we have loops added, and here there is literally zero manual work has been done. So I'll just directly go or move on to the model. Here's the model. So I'll just move into three viewports. So we can at a time we can see the plan view of the model. We can see the elevations as well as we can see a 3D. So how the element is going to be visualized. So we can see everything at this point of time. So initially we have started with the wall panels. So here we can see that I have just mentioned it as an EWP. Again, this is completely customizable. We can give any names as per our requirement. And once this is done, we can create the shop drawing out of it. So shop drawing creation is super easy. So we can just select the element and our shop drawings is getting created. So again, it's a template based. So based upon the templates or the standards or the kind of drawings or data that we want to use it, where we want to use the sections and all, so we can specify it. And this is generated within one click. So here we can see that there is zero manual work. So I just created the drawings, and this drawing has been getting created with normally the way we wanted it as one elevations, then a sections and a bottom sections, plus one 3D view. So with that, we also get the details of it. that is the mark number, weight, dimensions, thickness, concrete gate, and the complete bill of material is also visible over here. So these kind of drawings are generated with zero manual effort. So there is zero editing done over here. And not only this, so once the drawing is generated, the best part of the software is that we can work in either 2D or 3D. That means if I need to do some changes over here in the drawing itself, so any software will say that, okay, you need to do some changes in the drawing. So just close the drawing, go back to the model, do the changes in the model and come back to drawing, and then it will be getting updated. But that's not the case with the Allplan. So here, if we need to do any changes, what we can do is we can do the same changes in model as well as in the drawing aspect. So with the model, we are also getting, as we have seen, the bill of material as well as the complete dimensioning is also visible. So if any fixtures is added, removed, or shifted or modified, it will automatically change the things. Let's say, for example, here we have added some of the grout tubes basically, which are at the distance of 200 mm, sorry, 400 mm each. And the tag that is given is 3 number tag. So 3 number tag is basically for a 51 mm dowel for connections. So if I need to change or modify or add any particular grout tube in between, we can do that. So we can do it at any point of time. So let's say if I just select this particular dowel tube, and if I need to add one more dowel tube, let's say at a distance of 200 mm, so I can do these changes in the drawing itself. So for that, I don't need to go into the modeling and do the changes and come back to my drawing stage. So that's not required. So I can just drag it or I can just copy it from one location to another. Just I'm copying it at the location of 200 mm. And with the copying part, so we don't need to worry whether my dimensions will get modified or my bill of material gets modified. When we are working in a 2D atmosphere, like in AutoCAD or any CAD platform, so if I do any changes in my drawing, I need to ensure that the dimension is also getting updated. So again, there is an horizontal dimension, vertical dimension, all the dimensions needs to be updated. And with that, the bill of material needs also need to be updated. So here you can see that once I just copied it, it automatically adds the dimensions or modifies the dimension as it is. So, and not only that, it also changes. So initially it was having $7 tubes for connections, for bottom connections. Now it is converted to eight. And not only in this model, so it also gets converted or these things is also getting updated in the model stage as well. So whatever changes we are doing in drawing or in model, your model is completely updated at any point of time. So that is the USP of the software, that the person has the freedom to work either in drawing or in model. So I just modified some things over here, but we can add any rebar or we can add any particular detail at that stage as well. So this is the uh, grout tube that I have added. I just copied one grout tube from side and put it at 200 mm. But again, if we do these things in drawing, we need to ensure that the bottom of the top connections where these tubes are getting updated needs to be added or changed. So that the USP of the software is basically working 2D or working 3D, no issues with it. So now coming back to my presentation mode. So this is a drawing which has been created for walls with zero or minimum amount of manual work. And any kind of changes can be easily handled. So let's say there are some changes from the client end. So these changes we can do it itself very easily. So we need to worry about it. So moving ahead, so these are some of the drawing examples again for walls. So this is the short drawing for the rebar drawing. So wherein we are getting the bar bending schedule. This is as per the UK standards bar bending schedule, but the same logic we can use it for the US standard as well as if there is some changes is required in the bar bending schedule or the style is different, everything can be modified. So the software is fully customizable, so it can be changes can be done as per the client standards. So moving on, so something similar we have for the columns and beams as well. So we have typical macros available for columns and beam, so with which we can add corbels, add rebars with one click. So in the first slide, we have seen that there is something called as one-click reinforcement. So one-click reinforcement is basically a Python parts that we call it in Allplan. So with just one click, it does the complete rebar with spirals, main bars, and everything in the model. So I just go back to my model and this time I just opening a column. So I'm just taking a simple example for columns. So here I have some columns available. I've just purposefully taken it outside so that it should be very easily accessible or easily seen. So herein we can see that I have a dense rebar, grout or tubes at bottom. Then I have lifters at top and as well as some dowel tubes or dowel bars are also provided. So like this we can check it here that these dowel bars are also available. Then we have lifters at top and the tubes for this as well. So once this is done, so again the logic is more or less same here. So we can create a drawing out of it. So once my modeling is done, so I can just go into the elements and let's say I just want to create an element for the column number 5. So with one click, I get a complete drawing, which will be having elevations as per the client standards required. Then it also has the, I'll just make it full view. So all these things has been created automatically. And not only that, it also specifies where my sections are needed. So generally sections are needed at bottom side to specify the bottom connections with the foundation as well as the top connection with the top column or maybe at the end. Then we also have the connections in between wherein a bin can sit onto it. So these kind of dowels we can add. And so wherever needed, the connections that we can have the cross sections added. So with this, again, we are getting a complete bill of material. So any changes can be done at this point into these drawings and the same changes will get updated in the modeling aspect as well. So here the logic is more or less for all the drawings. The logic is more or less same that we create the once my concrete model is done, fixtures are done, rebar is done, then I can create the drawing and the drawing will be there will be less to no work needed to be done in the formwork drawings. So once this is done, I'll just showcase one more thing. The best part of the software is the iTrigger function. So this iTrigger function basically defines the sections or the levels. Let's say this is my column here. I can specify where my elevations are needed and from which directions I need to take these elevations, as well as here I can specify where the sections are needed. Let's say I need a section at top. I can specify that I need a section at bottom, then I need a section at somewhere at the center to take the middle corbels in consideration. So all these things can be easily handled here. So I'm just closing this iTrigger function. So the same logic applies to any precast element that we are creating over here. So with this, we can create any kind of drawings and the drawings manual work needed to be done is very less to minimum or negligible. So that's how the drawings are made easier and faster. So coming back over here, so these are the some of the, I'll just go back to the reinforcement part over here. So we have again something similar logic as Python parts. So we can select, let's say I have 10 or 15 number of columns, so I can select the column and we have complete tools available. So based upon our requirement and design aspect, we can do the reinforcement for this particular columns. So here a complete list of column is getting selected or it is getting highlighted. And based upon our design, we can check, we can do this individually as well as we can do it in the group wise as well. But generally, people prefer to use it as single at a time. So here you also have an option if we have a slab at top or a column at top, because if we have slab at top, then definitely the bars will be bent inside and it will be trimmed over there. But if we have column on top of it, then we need a connections to be given on top of it so that my double bar should go up. So all these facilities are possible over here. So by default, we can just pick it and place the column rebar as per our requirements. So let's say if I have column of 400 by 400 and typically it has got the same kind of rebars. So I can select it with this and all my columns will be all the rebars will be added to it, and this can be changed at any point of time. Suppose there is a change in design, then maybe we can change the column rebar and the diameter or spacing or the stirrups diameter if it is changing. So that all these things is completely customizable. And with that, we have the facility of adding corbels as well with rebars. So here is one particular column. Suppose the sizes is slightly different, and maybe its rebar requirement might be slightly different. So we can select it, and it's irrespective of the sizes. So software automatically identifies the sizes of the column and the geometry, and we can obviously here we have option for cranking as well. So let's say we have column on top of it and we need to give it a cranking, then we can select over here the cranking option. If we need to give more than one stirrup, then we can specify that as well. So these macros are very easy to handle, or these components or the Python parts basically are easy to handle, and we have a lot of options or varieties to provide the stirrups. So herein we can see that we just need to add one stirrup in between, so I can just click it as per the design requirement and the stirrups will be getting added. So here we can say that more than 70 or 80% of the rebar requirements for column can be handled with it, but there could be some situation wherein a normal manual rebar has to be added. So even a manual rebar addition is easy. So if I need to add some manual rebars, so software automatically identifies the geometry of the part and it adds the rebar to it. So that's how the rebar works. It's super easy. The rebar for columns is easy and can be handled at with ease. So some of the sub drawings, this drawing I think I have already demonstrated, wherein we can create elevations at let's say view one or view two or whatever the client requirement is or whatever the factory standard says. Based upon that, we can create it and we can create the cross section at any point of time. These cross sections can be stretched, modified, and manual work can also be done over there. So same logic applies for beam as well. So here we have some of the beam macros available. So the beam macros, this is basically for continuous beam, but same logic applies for the normal precast beam as well. So we can use the beam macro, we can select the beams that are needed to be reinforcement, and we can select the columns wherein these beams are sitting, and based upon this beam height, we can change the individual rebar for beam, we can change the individual stirrup segment length, spacing and all. So all these things can be easily handled with ease and with the Python parts that are developed with the softwares. So with these kind of tools available, the modeling of rebar is becoming easier. So it's not the way the 2D works, wherein each and every rebar has to be modeled or it has to be drawn. And once this is done, then it has to be done with the help of Excel or a BBS in the drawing aspect. Let's say if I need to bend the bar at end, so herein we can choose the bend length and all, and based upon this data that we are entering over here, it automatically gets updated. So these tools are easy to handle, and with these tools, the modeling of rebar becomes easier. Moving ahead, so these are some of the typical examples for the beam. So I just taken some simple examples wherein an inverted T beam or any kind of beam can be easily handled, whether it's an inverted T beam, inverted L beam, or normal rectangle beam. So here we have a 4-point lifting system, and complete bill of material is also added with the sheet. So this is the rebar drawing wherein a complete bar bending schedule with the tonnage and everything can be seen over here. So adding rebar or adding fixtures or creating any kind of complex geometry is super easy. It's not only, I mean, if we are getting some 3D model from any other software, we can take that also. And with that, we can go ahead and we can do the fixtures adding or rebar adding, and drawing generation can also be taken care of. So this is about walls, columns, and beams, so which are basically the prime elements that are required for precast buildings. But other than this, there is something special which is called as volumetric precast elements. So volumetric precast elements are sometimes called as PPVC, RMBM, RMB, or RUB. more or less the logic is same that instead of creating one beam, one column, or one slab wall, it can be done in a 3D. So this is basically precast, pre-finished volumetric construction. That's how it is called. So herein, there are various methods or various different types of it. So this is something very normal column, beam, and the top slab has been constructed. The internal parts can be done with the brick walls or any different kinds of material or the insulations. So this is completely done in 3D and casting is also done in 3D. Then there is one more type wherein vertical walls and horizontal slab is casted at one go in precast. Then there is the third one, which is again all the walls on four sides plus top slab has been casted. Again, there is connections is there with the top element and the bottom element, or other foundation at the bottom or above levels. There is connection as well as there is side connections. I'll just go in detail about this. So this is the finished product. So herein we can see that not only it has got all the fixtures, it has also having the inserts or the electrical conduits or the electrical boxes that are needed. Sometimes plumbing openings are required, sometimes small openings are required, or windows, doors are required. So everything can be casted at one go. So this eases out the work and it expedites the work. So let's say, for example, if this particular element has to be casted in precast, then it would have been requiring three walls and one top slab. So instead of four different elements, and there is again a chaja is also there. So instead of having it in three parts, a single unit is can be also created. So this kind of construction has started or it's going on for a few for some times here in India as well. So it is also called as pod, wherein a complete unit can be created. Some companies are also creating the washroom units or toilets unit in one block like this. So it eases the work and it expedites the site time as well. So this is something which is very useful. So I just showcase one small model for this, wherein a complete pod can be created. So this is particular example. I'm just showcasing the 3D part first, and then I'll go into the 2D aspect. So here we can see that a complete 3D element. I just go into the wireframe mode with rebar, bottom connections and top connections, side connections, everything has been created. And I just go on and with this opening rebars, extra bars at opening, as well as we may have, if there is some bigger sizes opening, then we may have to add some extra reinforcement at top. So all these things has been modeled and uh, we can create the drawings out of it. So this is the 3D view of the particular element. So now I'll move on to the plan view. So, so here is the plan view wherein we can see the complete connections. So this particular connections is available. And then we have the bottom dowel connections is also possible as well as the rebar. So I just create a drawing out of it because that's what it is going at side. So here we have this element and I can just select it and let's say create the drawing for this. So the template work has been done in such a way that there is minimum to no work needed to be done in drawing. So this is the drawing wherein it gives a top view. So top view shows all the top connections plus the dowels, plus the lifters that have been added. Then it has the views in for all four locations. So these are the four views. So left, right. So all these views are provided with all the dimensions, settings, and everything. Then we have the connections at bottom. So this is basically the bottom view, wherein the bottom connections are specified. So bottom connections are basically the for connecting into the foundation or connecting into the bottom element. So all these things are being modeled. And the same things we can view it in a 3D. So providing a 3D view in the drawing itself makes life a bit easier for the person who was working at the factory. So here we can see that these are the top lifters, top four lifters that have been added, and top connections has also been added over here. Plus the side connections. So these kind of pods are laid side by side as well. So there is a side pod also available. So the connection is also provided at this location. So creating this is super easy. and it takes lesser time as compared to a 2D or a popular 3D softwares that we are having. So, and the most important part of this is the change management. So, let's say if there are any changes that are needed to be done, these changes are easily handled by the softwares. So, assuming that there are some extra lifters are needed, or let's say I need to add some grout tubes at bottom. So, let's say here we have some grout tubes mentioned over here. The grout tube is the part B basically. So B is placed at a distance of 1000 mm center to center. So here in we can see this. There are total roughly about 19 grout tubes are provided. So if I need to change something, I can just copy it here itself. So let's say I just copy this particular dowel tube or a grout tube, and I can just say that okay, I need one more grout tube at a distance of 500 mm, and with this copy options or with this changes here, so it automatically adds a dimensions to it. So there are less to no chance of human error happening, because generally if I do these changes in any 2D software, there are bound to happen. Pick point errors might be there, or maybe sometimes missing dimensions might be there. But here it also updates in all the views as well as my model. So here initially we were having 19 dowels tube or grout tube, now it is 20. So with this, here also I can just move on to my drawing, and I can check that at this location one extra dowel tube has been added. So it makes life much more easier. Checking error, change management is much more easier, and the time required for these kind of changes is less as compared to the other softwares. So it makes because of these things are the big, and the fixtures that I'm talking about is also easy. So we can create fixtures in real time. There are a lot of there are different types of fixtures. So fixtures are basically the intelligent fixtures also, wherein we can put all in one go. The fixtures could be and normally like just added one it, and it should be shown in the drawing. So any kind of fixtures can be easily handled. So this is about the pod or the PPVC elements that we are talking about. So PPVC elements are growing in market, and a lot of companies are using these PPVC elements or ready manufactured building modules that we call it here in India. So I believe this is something which will definitely pick up a faster rate. So these are some of the drawings. So this is the same drawing that I have showcased here. So these kind of drawings can be created within no time. So just imagine creating these kind of drawings in AutoCAD or a plain 3D atmosphere, wherein all these things has to be done manually. Coordination is again a bigger problem. So there may be 5 or 6 different people working on the project. So all these people doing this work in 2D atmosphere, coordination issues, or if the changes or if the connections has been modified in one element, the same has to be taken care by the second element as well. So these things does create a lot of issues and problems. So creating a centralized model for this and completing it in Allplan is easier and less time consuming. So moving on next. So other than this volumetric element, we have foundations as well as staircases. So I just taken a simple staircase, or rather typically different staircase. So these kind of staircases can also be created with Allplan. And other than the simple dog-legged or plain stairs, so these kind of complicated stairs can also be created. So once my model is created, my drawing is created, next steps comes up is the putting this output format, right? So putting this because the thing that goes in factory or at site is the drawings. So many times these drawings, I mean, once the production is done, modeling and drawing production is done, the next part comes up is about the fabrication. So here I'll be talking under the drawings. So drawings are basically can be these are created from the 3D model. Drawings are often basically the views that are created. So dimensions and designations are often manual. So this is the traditional approach. So basically when we work on any 3D or a 2D platform, so dimensioning and designations or tagging is basically manually has to be done. But the approach that we take is the eye trigger option, wherein we can specify at what location we need the sections, what are the various views that are needed, What are the various types that is needed, will bar welding schedule as the bill of material. There could be different set of drawings for formwork, different set of drawings for rebar, so we can specify it as per our requirement. So this complete scenario is user based. That means based upon the company, based upon the user, based upon the standards, we can modify it. So this is our approach for fabrication. So this is something I figure what I was talking about is we can create these kind of templates for any elements. Let's say an wall panel may be having 10 or 15 different kinds of styles or requirement. So we can create that many templates so that the same templates can be used across the project. So there could be some situation wherein a different template is needed. So we can create it and based upon length or based upon the thickness, paper sizes and all, we can use it and utilize it to expedite the work. So again, we can have different set of drawings for rebar, as I said. So all the dimensioning for rebar can also be easily handled. So there should be less or minimum amount of manual work needed at for the drawing generation. So here is a simple example. And we have the possibility of working in 2D as well as in 3D. So this is for a simple wall panel. So let's say this wall panel is needed to be, a drawing has to be created for this. So we can just select it. We can, based upon the viewing, we can change and we can select the element. And this particular wall, we're just creating a drawing out of it. So once the drawing is created, we can specify here which template has to be taken care of. So there could be a number of templates for wall panels. So we can select it based upon the standard requirements, and this particular drawing is created. So this drawing is having all the information that is needed, basically all the bar bending schedule, bill of material, everything is inside the drawing. But once the drawing has been created, there could be some changes. So this is particularly for the elevations that we are seeing, and this the particular view is also showcasing the isolation layers, and herein we can change it as per our requirement. If I need to see the rebar, so if I have the bottom views for rebar, so I can just switch on and off. And based upon that, the rebar tagging is also get coming up. So all these things can be customized as per the requirement. So there could be chances that we may miss some of the connections or inserts. So we can do that in the drawing stages itself. So my drawing is open here. So I can select any particular connections or inserts or fixtures that I needed to add. And the same fixtures can be added at any view. So here it is the bottom view connection that is getting added at a distance of 400 mm. So once this is created, so the same, we can see that in this right side central perspective view number one, the same fixtures is getting added as well as it is getting updated in the top view also. So we don't need to worry whether it will be coming correct at the correct location or not. And with that, sections or the detail of it is also getting added, as well as the rebar is also getting cut if it is required to be cut at that particular location. Even that possibility is there, and it will automatically get updated or added in the bill of material. So these things are super easy. And not only this, so first insert we have added into the drawing. Now we can go back to model, and if I need to add something in model, I don't need to change the drawing. My drawing is getting updated side by side. So I don't need to worry about whether to work in model or to work in drawing. So I can work at any point of time at any locations. And you can see here the C was basically the 4 pico inserts are added. And the same thing has been added into the rewired view as well as the top view. So these kind of things makes life easier, and the error chances are very less to minimum. Then the software can also be used for 3D tendering models. So this is something very interesting, wherein there could be, let's say, a company may be giving 10 to 15 projects for tendering purpose every month or every week. And for each and every project, it becomes difficult to give the exact quantity or near to the exact quantity. So we can create a quick 3D model for tendering purposes, So these 3D models gives a fairly accurate, I won't say 100% accurate, but it's say roughly about 95 to 105% of accuracy is there. So with this, we can get how many double walls are required, sandwich walls are required, hollow core slabs are required, how many columns are required, so that once my tendering model is done, so it gives the tendering quantity which is fairly accurate because it has been created in 3D. So generally for hollow core, we need to have how many square meter of hollow core is required. For wall panels, we again may be requiring how many hollow square meter is required. For other elements, we may need a number of elements or the cubic meter of volume for concrete is needed. So any kind of units, we can create a quick 3D model, and based upon that model, we can give it for the tendering purpose. And our tendering models or tendering quantities will be fairly accurate. And if the project is getting awarded, then the same project can start for the detailing phases as well. So it doesn't stop at the tendering stage. So we don't need to scrap that particular project once it is awarded. So we can continue with it. We can add fixtures, we can add rebars to it, and we can create the shop runs from it. So it will make the life easier. Tendering will be accurate. And once the tendering is done, the next step for creating drawing and model will be fairly easier and faster. So that's the basic advantage of creating the complete model into BIM platform instead of working on a 2D platform. So it makes life easier. Then once my model is done, tendering is done, model is done, drawings are generated. Next part is the production. So for post drawing and modeling stages, the part comes up is the manufacturing or the manufacturing execution system or the MES system. So here again, we have the possibilities of using Allplan. So Allplan is connected with nearly all the CAD/CAM machines, whether it's a Unitechnic, Progress, Bullard. So it is connected with it. So we can export our data inside from Allplan so that it will be error free and there should be, I mean, zero paperwork. So to complete, I mean, we can export it to the PXML format. So PXML is basically used by the progress machines. So if we have progress machines or evaluate machines, so we can export our data. So it enables automatic production of carousel systems. So data format basically for progress machines and automations. And it is also created, I mean, we can export this data from Allplan Precast itself. So for the companies who are having their own precast plants, then definitely this is a boom. And many times customers' requirement is also there for exporting the PXML format, then this is the best option. Because I mean, if you're working in a 2D platform, then again, it is not possible to get the PXML out of it. Then we also have the Unicam. This is for the OLAT machineries. So we have the direct tie-up with this, and we can create the file format. So basically we can do it PXML, Unicam, RNB, so IFC4 format. So all these formats are possible from Allplan directly and no need to do any manual work of that. So basically MES system or smart factory, then the software is capable of it. So it's always accurate. It's 100% accurate. It's reporting is 100% there. So we can get any kind of reports out of the model and it's completely paperless. So herein we can see some of the big screens are placed near the factory and it's 100% paperless work can be done. So once this is done, the model next step goes to the site, which is basically the BIM Plus. So we can upload our model onto the BIM Plus software, or it's basically a cloud-based platform. So the same model will be there from the factory as well as the same model can be seen at the site as well as the person who is doing the detailing or modeling for this particular project, the person can work on it. So what's the benefit of have using Allplan? So herein we can have all the stakeholders at one location, one platform, which is basically BIM Plus. All the drawings will be real time and updated. So we don't need to worry about whether my drawing is updated or not, whether my models, my drawings are as per the latest set of models or not. So we don't need to worry about it. And this is again a cloud based. So this is just a rebar system for a small bridge project wherein a complete rebar details can be done. We can extract the quantity out of it. We can check and If there is any problems at the site, we can see it from here itself. And it is generally said that if it fits in the model, then definitely it will fit at the site. So that's how the software works. So these are some of the case studies. So these are some of the projects that has been done in Allplan. So herein the client says that more than 50% of time saving is there. So initially it was planned to complete this project in 5 months, but it took less than 2 months to complete this project. There was quality was very high and there was 60% less error while doing this particular project in Allplan. So I'll showcase some of more things as well from here. So these are some of the case studies. Again, this is I'm taking some different kind of case studies here. So this geometry is slightly irregular geometry, not the standard one. And again, we can see some of the different kind of textures also. So we can handle these kind of things as well in Allplan. Then this is again one more building wherein brick snaps are with claddings has been used. So the software can easily handle these kind of things. So it is not only related to residential and commercial complexes, we can use it for stadiums as well. So this is one stadium which has been created with help of Allplan. So these are some of the case studies. Then here, this is one more building which is basically done in Switzerland. Again, completed with the help of Allplan. So we can think of any kind of precast project and the project can be done with the software. So this is one more case study. So again, the German company. So the complete project has been done in the software. So these are some of the global customers that are using our softwares. And so to sum it up, what Allplan Precast can do is, so we can create any kind of model. Um, we can import the model if it is done in some other software, the same model, we can import it from the softwares and we can continue from there itself. Or else we can start it from here. We have some ready-made tools out here, so I'm directly going now to the software part. So I'll just make it a bit simple over here. So here I have basically a plan view, a 3D view on top, and an elevation over here. So modeling here is simple and it's super easy. So herein we have some of the real tools are available, which are basically for wall panels. So any kind of wall panels can be created with this. Any kind of slabs can be created, columns, beam, foundations. Then we have some dedicated tools for stair as well. So here are various kinds of stairs that can be easily handled with it. So now going on to the wall panels, so I'm just using a simple tool here. So wall panel can be a straight, a rectangle, arc, or can be having any shape. So I'm just putting one simple example, a straight wall panel. Again, we have the feasibility wherein we can change, let's say I need multiple layers of walls. So I can select it from here also, and based upon the requirements or the design, I can change the height or thickness from this particular location. So let's assume that it's a straight wall and I can just go on picking it and wall panels will be created. So once this is done, there could be some openings out here. So I can see this in all the three views. So the usability of the software is, let's see if I'm talking about any 3D particular software, they first create a 3D model and then go ahead. So herein, I'm basically working in 2D and my model is getting updated or populated in the 3D atmosphere. So once this is done, I'm adding a door opening here. So you can see that once it is, I'm just selecting it, I have not clicked it yet, and the door is getting highlighted in the elevation as well as in the 3D view. So I'm just placing it at some different locations. And again, we have the options for changing the size, changing the shape of the door, or if I need a curve on the top of it. So all these things can be handled easily here. So herein I'm specifying that I need a door at 1000 mm, and we can specify on which side it is needed to be opened. You can escape it if it is not required and my door is placed. So my command is still active. So if I need to add one more door, I can do that, or I can just press it at an escape button and my door command has been escaped, but my door has been added to it. So similarly, the rest of the elements are more or less on the similar lines. Let's say I need to add some windows out here, and I can do that, and I can just specify some distance out here, and here is the distance that I wanted my window to be placed. So you can see that in the 3D view, the windows has been placed as well as in the elevations. So once this is done, the next part will be adding the rebars to it. So we have some automated tools available over here. So based upon our requirements, the elements. So here you can see that we have tools for beams, columns, punching shears, column connections or wall connections. So whatever data we needed, we can select it over here. Then we have the options for adding one more wall at top if needed. So I can just select my wall panels and my rebar will be added. So it automatically adds the rebar, it adds the trimmer bar, the 45-degree bar at end. It also adds a U-shaped bar at end if required. Again, this is completely customizable. So if there is design, if there is changes here, we can do it. Let's say if I need to change the bar diameter, I can select it from this stage. Then here we have the main rebar options, wherein we can change it if I need it as a mesh rebar, or if it is a bar reinforcement, I can select it from this locations. Then if I needed some pins or stirrups, so these are the options that are available for adding pins. So here are the pins that you can see it at this locations. And if it is not required, then maybe I can skip it. Then we have the spacer bars. So generally spacer bars are provided. So from the image itself, it will be clear that spacer bars are basically creating the spacing between the two layers of rebar. Then we can also have the clamping. So these clamping bars clamp the layers, or if we don't need it, so we can just skip it and we can escape from this. So once this is done, I can just say close button and my rebars will be added. So this makes life easier, and wherever the openings is coming up, it automatically trims the bar and we don't need to worry about this. So this makes adding rebars super easy. So something similar, we have the tools. Actually, this has been already shown, but I'll showcase it again. So let's say I don't need a chamfer at edges. I can say a column of 600 by 400 and I can place it. So this way we can place the column. It is available in 3D. It is available in 2D as well. And based upon our requirement, I can just go in and select the rebars. So nearly, I maybe at certain cases, 100% rebar can be achieved with this, or more than 70% or 80% rebar is possible. So here we have the options for changing the main rebar. Suppose if my slab or this column is getting terminated at the slab level, then we can have an option for adding an L bar extra at the top. Then we have the options for changing of stirrups. So we can edit the regions. So by default, if we need to give L by 4 or L by 3 or L by 5, we can specify it at particular locations. Then sometimes it is needed to give the sections. So we can select the sections. And once this is done, I can just say close. And if I need to place the section there and there itself, so I can just click on it and the software will automatically add the sections at the predefined locations with the rebar tagging method. So with this, and you can see that the rebar tagging has not been visible into the 3D because in 3D we'll be only seeing the concrete and rebar, all these options and not the labeling part. So this makes life much more easier and the work that we are doing is much more faster. So once this is done, we can also check if my rebar is as per the if it is completed or not. So I can just click on any rebar and we can say reinforcement bar legend. And herein we have various options available. So the first option that we are seeing is showcasing the bend shape as well. Suppose if we don't want bend shape, then we can say about the second option, which is without bend shape. Then the fourth option is we are having the ACI shape codes as well uh, as per the ACI standard or the US standard. So I'm just taking the first option over here and I can place my rebar, I can place my BBS. So it will take all the rebars that have been showcased in this particular drawing. So this particular drawing is containing a lot of elements over here and it gives the default output the way it is required. Again, it can be customizable as per the requirement. So this kind of rebar output can also be generated to cross check it and to check whether it is done properly or not. let's say if I just delete some of the rebars or some of the bars from here, I'm deleting some of the column rebars. So you can see that it is automatically getting updated. So we don't need to worry about that if I delete something or if I add something, whether my bar bending schedule is getting automatically updated or not. So all the quantities and everything will be auto updated and it will be auto generated. And once this is done, we have again the options for exporting this to various formats. So here we have the various formats that are available. So we can export it to IFC, we can export it to 3D PDF, then SketchUp, Rhino, by default we have AutoCAD options. We can export it to microstation data or we can upload it to the Build Plus data as well. With export, we have the import facility as well. So herein we can import any CAD file, microstation, PDF, IFC. We can import the direct Revit model as well, so that it can be taken from that stage. So we don't have to remodel the whole thing again if the some project has been done, architectural has been done to Revit or some other softwares that is possible. So this is a real good software, a real good tool for precast industry. And not only that, it also does architectural work as well. So I'll just open a small project from here. So herein we have some architectural features as well. So we can create this kind of architectural and I'm just opening, this is the drawing portion that I was opening and I'll go to the modeling aspect. So here is my model. Yeah. So we can see that we can create an architectural model as well. And I just switch on few of the things. So this particular software is drawing based, so we can switch on and switch off whatever things that we are needing. So once we switch on the things, so here a complete model is seen. And this particular model has got all the data. It has all the architectural things. It has got, if I just move into the wireframe, you can see the rebar is also placed inside it. To some extent, I'm not taking it for the full, but rebar has also been modeled inside it. So whatever things are needed, we can check it and things can be added. So I'm just adding some more rebars to the scene. So once this is clicked, here you can see that the complete slab, wall, everything has been modeled or the rebar has been modeled. And again, all the architectural features and everything as is present inside the model. So that's the USP of the software, wherein all the things can be done at one location and whether it's architectural, structural part, precast part, manual, some CIP rebar is there, casting place rebar is there. So complete 3D package can be built, or complete 3D model can be built at this particular locations. So I'm going back to my presentation mode. So other than this, Allplan also can does the bridge modeling as well, but we will not be going into the bridge modeling. So till now, what we have seen is the software can be used for creating tender models, which gives fairly accurate amount of quantity of drawings, which is required for the estimation purpose. And once the tender model is created, we can take it forward for the detailing, modeling and detailing or drawing generation, as well as the post productions. We can handle complex geometry. This is something related to bridges as well as it is also related to precast. So if there are some facade elements and all which has to be created with precast, then it can also handle complex geometry. Then sometimes visual scripting is needed. So other softwares for that visual scripting, we need to rely on Grasshopper, Rhino, or Dynamo, but we have inbuilt visual scripting so that we don't need to script to any other software wherein again there are chances of data losses. So inbuilt visual scripting is also available. Then we have automated complex reinforcement can be done. So some of the examples over here. So we have both the options possible. So complex reinforcement can be automated as well as it can be done manually as well. As then we have automated precast design. A complete automated precast design can any kind of precast element can be done. We can do infrastructure projects, so whether it's a bridge, culverts, tunnels, highways, anything can be done over here. This is something which is useful, but not much in the precast, which is basically the formwork modeling. So some companies are also doing the formwork modeling. So this kind of formwork can be modeled with the help of Allplan. Then we have highly automated fabrication process. So we have linked up with the UV technique, we have linked up with PXML, BBVBS, ASA format. So any kind of data format data needed from the software can be done from here. Then we can do the site planning as well. So when I'm talking about the site planning, so we can identify the crane location, we can identify the pits, sump, and the excavation quantities if it is needed. So all these things can also be done. So let's say while starting the site, the first part comes up is the excavation. So we can do the excavation quantity as well. So we can find out how much quantity has to be excavated to achieve the level. There could be various layers in this soil. So again, it can be classified based upon that. So any kind of site planning, road planning can be done with it. Uh, it's a model-based scheduling. So once my model is there, so complete scheduling can be done from the model itself. So we don't need to rely on the softwares. And again, we have Build Plus Cloud Platform, wherein we can the same model at one time, multiple people can work at the same locations. So that's to sum up about it. So Allplan can be useful for precast, bridge, road, architectural, and we are located in Mumbai. So our main office is in Munich, but in India we have offices in Hyderabad as well as in Mumbai. So we are reachable. So for any training needs, software sales, we are reachable over there.